So today's work, we are moving on to radical functions. We've covered absolute functions. Now we're moving on to radicals. It's going to be very similar to Friday's class where we're going to kind of learn about them, learn about their graphs, and then use those graphs to help us solve equations. So starting off, just getting a couple of key things down on our notes here in this top section for radicals. A radical uses square roots, cubic roots, etc. And these roots will be written with the radical sign or using fractions as exponents. So anytime you see this root sign or a fraction exponent, we're going to be dealing with radicals. And kind of the key point here is that we're going to see these things listed as either way. The square root of 9, which we know is equal to 3, that can also be represented as 9 to the 1/2 power. That 1/2 exponent, something to 1/2, that is saying the same thing as taking the square root of that thing. Okay. Just a funkier sign, but it makes it a little easier for us to work with. So make sure you identify those as interchangeable. Same thing here for our cubed root. The cubic root of 125 is the same thing as 125 to the 1/3 power. All right. And in this case, well, let's back up. In the case of the square root of 9, we're thinking of what times itself equals 9, or what squared equals 9. In that case, it's 3. For the cubic root, we're thinking of what times itself twice, or 3 times in a row. So what to the 3rd power equals 125. And in this case, we would have 5 to the 3rd power, because 5 times 5 gives us 25. 5 times 25 gives us 125. So on your note sheet, there's a chance to just kind of practice working with this stuff. 10 problems. So try out just evaluating these problems and be on the lookout for the differences, similarities when we see the radical sign versus that fraction to the 1/2 power. Work through that. Check your answers against someone else. Use your calculator to check your answers. And then when you're done, unpause your screen and we can move on to the next part. So now that we've had a good refresher on what radicals are, what square roots are, what cube roots are, excuse me, we are going to kind of mimic that same thing we did on Friday with our absolute value graph. We're going to do it to explore our radical graph. So first thing we should do is punch in this equation into our Desmos. So if I go to my Desmos screen, we'll have f of x equals the square root of x, and you can either type in SQRT, let me do that again, SQRT, in order to get that square root sign, or if you want to, you can, oh, my little screen's in the way, you can use this keyboard here down in the bottom of Desmos and find the square root symbol and then type in x. So now that we have this graphed, let's make some observations about it. I think one thing we can note is it starts at the origin. It goes on to the right forever. It does kind of have a curve to it. And just simply jot that down. Then what you should do is add a new graph. In this case, it'll be square root of x plus 3. So I'm going to go ahead and type this in. F of x equals the square root of x, and make sure that plus 3 is outside. And make an observation about what changed with our graph, right? How did it shift from our original? In this case, it looks like it went up 3 units. So just on some scratch paper, work through this list here and kind of repeat that for all these functions. Get some exploration of what our graphs look like and how they shift around based on our equation before we formalize it into notes. Once you've done that, unpause your screen and we can move on into that note section. All right, so this note sheet is going to look very, very similar to the one we filled out on Friday. We are going to first kind of sketch the shape of our graph, so that f of x equals the square root. Remember that it started at the origin here, kind of started going up and then softened out and leveled out a little bit, but it did go on forever to the right. Notice how I'm not putting an arrow on this left-hand side. It is bounded at that 0 axis. And if we think about it, if we take the square root of a positive number, let's say positive 4, we get a value of 2. So our y value is going to be positive. We're above this y-axis line. And if we take a square root of a negative number, that -4, that is 2i, right? Which we cannot graph. That's an imaginary number. So notice how there's nothing that shows up over here on the left side of our graph. So let me just clear that out, re-sketch my graph here. Okay, now let's summarize what we learned about those different kind of translations and transformations. The first one, flipping the graph upside down, that was f of x equals, and we have a square root sign out in front of x. And then flipping the graph across the y-axis was f of x equals the square root, and that is a negative x inside. Now f of x going up c units, it was going to be the square root sign outside of our radical, so square root of x plus c. Down c units would be minus c. Moving to the right is our funky one. It's inside of our square root, but it is subtracted x minus c on the inside. And moving our graph left, again, it's funky. It's opposite what we expect, square root of x plus c. So just like we did on Friday, we're going to use these radical graphs to help us solve equations. So pause your screen, jot down these steps, but you'll notice they're the same exact steps that we took on Friday. We're going to treat each side of the equation as its own function, plot it in a Desmos, then find that intersection, and find the x values, because those are going to be our solutions. So let's try this out with example 1. Example 1, we have the square root of x on the left, we have 10 on the right. I'm going to say, hey, this square root of x, let's call that our f of x. Let's call this 10 our g of x. And we are going to graph and then find intersections. Graph, find intersections. Okay, so let's do that in Desmos. Let's clear out our old graphs. We have the first one, f of x equals the square root of x, and g of x equals 10. It's important, as some of you guys found, a quick mistake in there, to type in that g of x, otherwise it doesn't pop up on our graph. And we might need to zoom out a little bit on this one. We look here, okay, there's our g of x graph. It's a 10 value constantly. We're going to need to scroll all the way over to the right here, and if we click on our graph, we can see the nice line. Looks like our x value is 100. So in that case, our solution there, our x is equal to 100. And we could test that out if you wanted to. You can plug that back in and say, okay, does the square root of 100 equal 10? And yeah, it does. So that is indeed our solution. Okay, we could try this again for example 2. This time I'm going to switch up the letters a little bit, just so we kind of see that we don't always need to define them as f and g. Let's call that h of x equals 5x. And let's call the square root of 2x plus 3, let's call that k of x. All right, just switching up the function names to show that they aren't really important. But if we go ahead and graph this in Desmos, let's clear out our old stuff. We said we had h of x equals 5x. And k of x equals that square root. And underneath the square root, we have 2x plus 3. Let me home in my Desmos screen. We look here, and our graph looks like it has one intersection. And that is intersecting at 0.389. So our solution there is going to be x equals 0.389. It is very possible to have some nasty decimal answers as our solutions here. We're dealing with square roots. They're not always clean numbers. So final 2 examples here, a little more complicated in our equations. Tomorrow we're going to learn how to solve these by hand, but even these problems for examples 3 and 4 can be really difficult to do. So Same thing we did before. Let's set the left side to one function. Let's call this one g of x. Let's set the other side to h of x. And you'll remember that this 1/2 here is the same thing as saying a square root. So when we plug it into Desmos, we can do it either way. All right. First thing I'll do is I'll throw my g of x together. G of x equals the square root of 3x minus 1. And we called the second equation h of x. And that is equal to x plus 5 to the 1/2 power. And I'm going to add one more version of this in here just to prove that the 1/2 and the root sign are the same. If I type in square root of x plus 5, notice how my purple and green graph are exactly the same. Just a quick little side comment there, but I'll delete that. We look at our graph, we find that intersection. It looks like it is at an x value of 3. I'm going to zoom out a little bit to see that, all right, my graphs are splitting apart even further as we go. So taking that solution of x equals 3 should be good. So in example 3, x equals 3. And finally, in example 4, you can name these functions however you want to, and I'll kind of leave them blank right now just to let you have that freedom. And we'll go into our Desmos. We're going to put x squared minus 4 on one side. And I'll make mine f of x here, x squared minus 4. And our g of x is going to be equal to that second side of the equation, the square root of x plus 5. If you look at this graph here, we have two intersections, so that means we have two equations. There are two solutions. These numbers are not very clean. Looks like negative 2.371 is one of our solutions. X equals negative 2.371. And the other solution, if we look here, is 2.599. 2.599.